Now in this video, we're going to do an example subnetting. So let's say we have this address 192.168.1. Let's say 0. Let's go ahead and make this just a little bit bigger. Okay. Let's say we have this address with the subnet mask of /24 or 255.255.255.0. So the CIDR notation is the /24, and then here's the subnet mask. So we need to create subnets to support at least 5 separate networks within the organization, our hypothetical organization. So we'll start with the network address, which is 192.168.1.0 with the subnet mask of the /24. So that means we have 256 addresses that we can use, because the broadcast address is going to be 192.168.1.255. So this is going to be the 256, because 0.0 is the first address, .255 is the last address. But the first address and the last address is reserved, because the .0 is the network address. This is the address of the network, so this identifies the network. And then the broadcast address, the .255, is used to communicate to every device within that subnet. It identifies the network. And then the broadcast address, the .255, is used to communicate to every device within that subnet. Now our task is to create at least 5 subnets. This means we need to determine a new subnet mask that will allow us to divide our existing network into 5 smaller networks. Each subnet will have its own range of IP addresses. So to create 5 subnets, we need to borrow bits from the host part of our IP address. And in a Class C network, the host part is going to be the first 3 octets. This is the host. So this is the first octet, this is the second, and this is the third octet. So the first 3 octets are the host bit, and then this is our actual address. And then .0 is going to be the actual bit that gets assigned. So this is the IPs that we can actually use. Now the question is, how do we know how many bits to borrow? We can use the formula 2 to the power of n. So we'll go ahead and do 2 to the power of n. Apologize for my bad handwriting. I'm using my mouse, crazy enough. So n equals the number of bits. So for 5 subnets, we're going to do 2 to the power of 3, which equals 8. Now the reason we're doing 2 to the power of 3, is because 8 is the smallest power of 2 that's greater than 5. So we need a value that's greater than 5, that is the power of 2. So 2 to the power of 3 is 8, which is greater than the value of 5. So it'll allow us to divide the network into 8. But we'll only need 5. So that means, so this part right here means we'll have to borrow 3 bits for subnetting. Let's go ahead and refresh. So we'll go ahead and start with the default subnet mask for the class of our network, which is going to be a Class C network. So 192.168.1.0 is the default subnet mask. And then the default subnet mask is going to be that 255.255.255.0 or /24 for the CIDR notation. Borrowing 3 bits adds to the subnet part of the mask. So you add the 3 bits to the 4th octet. So the 4th octet, which is this 0 over here, this is what we'll have to add to it. So this subnet mask of /24 will have to add 3 to this part. So this will make it a subnet mask of 27. So the new subnet mask will actually be 255.255.255.224. And how do we get that? So how do we calculate the number 224? Or how do we calculate any of this? So the 27 stands for ones. So we'll have to count 27 ones separated in 4 different octets, the value of 8 per octet. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and then 25, 26, 27. And then the rest will be a 0 up until 32. So 27, 28, 29, 30, 31, 32. So this binary notation over here equals this subnet mask over here. Now, if you need help to better understand this, I may not be the best at teaching this part, but if you need help, I'll list some resources you can follow along and you can use as a guide that'll go and dive deeper in this topic. To calculate the subnet increments, the increment between subnets is determined by the value of the least significant bit that we've borrowed. So in this case, it'll be this bit over here. So this one bit, which equals to 32. Now, how do we get that number? Each octet, so each value over here equals a certain binary. So 0 will be 1. This second 0 is going to be 2, 4, 8, 16, 32, 64, and then 128. I'll go ahead and type this out since it looks really bad. And each octet, there are 8 binaries, and then we found the least significant bit, which is going to be this third one from the left. So 1, 2, 3, the value of 32. So 32 is going to be our decimal value. So this is the value in which each subnet will increase. Now let's go ahead and clear this out. Now, starting with the base address of 1.0, we can add the increment to get the next subnet. So going by 32s, 192.168.1.0/27. This is the first subnet, and then the second one, third one, fourth one, and then the last one, 128/27, and so on. And then we can keep going until we exceed the address space. So within each subnet, the first address is the actual network address. So the .1.0 is the network address for this subnet. Let me go ahead and type this out. So this first address, the 1.0, is the network address. Last address in this subnet is going to be 192.168.1.31, and this will be the subnet address. So what's the usable space that we can use? So all the usable addresses, well, this is only going to give us 30 different addresses that we can use. So for usable, we're going to have 192.168.1.1 all the way to 192.168.1.30. So only these 30 addresses are going to be usable. The 1.0 will be the network address, and then the 1.31, this is going to be the subnet address. So right over here, these 30 addresses can be assigned to devices like computers, printers, or other network devices. Now we quickly went over subnetting. This is just a really brief walkthrough. If you still need more resources to grasp this concept more, this was probably the most difficult part in cybersecurity, is the networking part, subnetting. A lot of this is automated now, so you wouldn't really have to do a lot of this hands-on kind of math. But if you need more resources, I'll drop some resources that you can follow or be directed to better understand this topic of subnetting.